Hi everyone, my name is Abdurrahman Ali, and today I'm going to be presenting my project about Tucson parks and recreation, land acquisition prioritization. As an overview, the purpose of this project is to identify and prioritize suitable location for new parks in Tucson that will be a valuable addition and enhance recreational projects. The benefits of parks and recreation. First, the health benefits. They improve physical well-being and reduce the risk of heart disease. For economic, they enhance property values and increase the municipal revenue. For environment, they limit the negative impacts of pollution and improve the quality of life. Looking to the challenges, Tucson is facing the same population growth issue as many other metropolitan areas. A significant challenge is responding to the diverse recreational needs of parks for growing population. The additional challenge is to formulate a comprehensive acquisition strategy based on several factors that will aid in accurate land acquisition. Study area. Tucson is located in southeast Arizona. It's a city in and the county seat of Pima County. As of the 2020 census, the population was approximately 543,000, and it's considered the second largest city in Arizona behind Phoenix. The city has a total area of 227 square miles. We can see on the right side the reference map of the Tucson City Study Area, which was created by ArcGIS for using the words layer at their name displayed in blue text. The analysis used for the study was based on the following factors. First, the trust for public land analysis surface, which focuses on area in a city that fall outside of the network surface area. Second, TPL priority points contain 5 optimal locations outside the 10-minute walk and 5 other optimal locations that mitigate the heat. The data for these two were obtained from the TPL, the park surf database. They are distant from existing parks. The data were acquired from the city of Tucson, up in California. Fourth, qualified census tract QCT. They are tracts that contain a large proportion of low-income residents. Fifth, the heat severity index. Data for the heat severity and qualified census tract were provided by the Pima Association of Governments. Six, accessibility. For accessibility, we have public transportation. These are streetcar and central bus stops, and greenways and bike boulevards. The data were obtained from the city of Tucson for this last one. Moving on to the method. A land suitability analysis was performed to help identify and prioritize land area for acquisition. The following workflow was taken to complete suitability analysis. First, standardized the criteria using an ordinal suitability scale. The scale was defined as very high, moderate, and low priority based on the scoring values. Then assign a scoring value to each criterion based on the importance from 10 to 1, as 10 represents the most important and the least. After that, complete total suitability by adding the scores from the last step and mapping criterion value to the suitability scale. Finally, the site with the highest overall score is chosen as the best site. So the higher a property score, the better it meets the community needs. A simple workflow diagram has been created to simplify the suitability analysis for obtaining land, as shown on the right side. Since the criteria were defined and the data was collected, we can assess the study area and use a spatial analysis tool as the next step to complete the workflow. Starting the trust for public land TPL analysis surface, a submodel of this layer and the other layers for each factor were built from left to right, to the right section being the output. I first used the union tool to join the priority area with the study area. Then I used the add field tool to add a field to the layer attribute table. After that, the calculate field tool was calculated the values for the added field, which is used to assess the layer. The score values were assigned to priority areas where the higher the score, the better it meets the community needs. For the TPL priority points, these are optimal points to show top areas in a quarter-mile radius that fulfill the new park's goal. For this layer, I use add field tool to run the optimal location. The values of the assessment were entered manually into the attribute table, which is why no submodule was built. I assigned the low values from 1 to 5 to the 5 optimal location outside the 10-minute walk, and the higher values from 6 to 10 to the other 5 optimal location outside the 10-minute walk, and mitigating the heat. Distance from existing parks. The first tool used was the multiple ring buffer tool to create buffer around each park based on the ranking demonstrated in the above table. As you can see, the distance on the left side of the table. Then I merged buffers with the study area using the union tool. After that, the combined output was clipped to the restrict suitable location in the study area with the flip tool. Finally, I used the add field and calculated field tools to run the add field based on our score from this table. The values were assigned to give the area near parks low score and far areas high score. To help find places far from existing parks and suitable location for new parks. Qualified census tract. This study must ensure adequate parks and facilities for low-income areas and ensure that these areas are not underserved. The qualified census tract was selected in the study area using the select tool. After that, I used add field and calculate field to evaluate these tracts. They were given 8 as a scoring value due to their importance and considering them as possible area for establishing parks. Heat severity. The submodel showed that I used the set node tool to identify cell location of below average 0 to 5 to no data in order to maintain the required high values within the raster layer. Also, the above average values from 6 to 10 were used as a scoring value for this layer. Then I used the raster to polygon tool to formalize the type with the other layers using the analysis. Accessibility and public transportation. For this layer, I used the multiple ring buffer tool to create buffer around each streetcar and bus stop based on the distance value shown on the left side of the above table. Then I clipped the buffer tools output there to restrict the suitable locations within the study area using the clip tool. After that, I used add field and calculate field tools to add values to the added field based on the score from this table. The value are assigned to give the areas near the streetcar and bus stop high score and outline area low scores to increase access to parks and open spaces in suitable location. Images and by polyvast access. For this layer, I used the same tools as in the previous public transportation layer. Also, the values were assigned to give the areas near green waves and by polyvast high score and outline areas low scores. The next step in the process from workflow is to overlap all the data sets within spatial analysis tools. Here we have the sub-module showing the process for suitability analysis that uses different spatial analysis tools, produce final output, and get suitable location for parks. Result, based on the criteria that have been set, the rank suitability analysis gives us an arrangement and classification of the possible places that can be considered appropriate and the rank of their importance. On the right side is a map that illustrates the area that would be most suitable or least suitable for parks as a raster layer. These areas were categorized into 4 classes, shown in graduate colors. From dark brown, which represent the very high priority areas, down to yellow, which represent the low priority areas. These classifications help expand the city, park, system, and meet with signal. The analysis result map was converted to a vector layer to enhance its appearance and better know the result. By looking at this map, you can see that the very high priority area focus on the northwest and southwest. This analysis laid out a vision to help define the long-term acquisition strategy, set priorities, and identifying areas for future acquisition and possible development projects to bring quality to the physical and cultural environment. To demonstrate the content of the study results more clearly, I use the section layer to display the outcome of the analysis map. As we see in this map, Each section represents about 1 square mile to facilitate the selection of suitable parcel based on the criteria used. Performing suitability analysis informed decision on prioritizing new acquisition, ensure that they provide significant value and benefit to the system and users. Also provide a secret roadmap for acquiring land for parks and development an equitable, sustainable, and resilient parks and recreation system. The model was created to update the layers of individual factors that go into the analysis in order to generate a new final map over time. The criteria used in this study area help evaluate and pursue potential acquisition by performing suitability analysis to ensure that parks are more inclusive and relevant to change and relevant to gains. Also, this ensures that the new park will be a meaningful and valuable addition to the park and recreation system. Here is the model that includes all the previous submodels. Shows suitability analysis by evaluating and overriding all the data set using spatial analysis tool and identifying areas for new parkland. This model can be used to create a workflow allowing the user to enter data and identifying location of new parkland where implementation of the acquisition can be achieved. The most suitable location were identified to be too sensitive for the future parks. The area with the highest priority focus on the northwest and southwest of the city. A model was created to update the individual factors involved in the analysis to create a new final map over time. All this results will assist in evaluating acquisition, making informed decisions regarding prioritization, and serve as a roadmap for acquisition parkland. As a future study, other secondary factors such as funding and proximity to the other services can be considered for this analysis result based on the condition and necessities of each project. Updated and new data for the study area must be provided to ensure that the parks system accommodates the community's needs and enhance the operational projects. Thank you.